Lasso regression is what is called a penalized regression method, often used in machine learning to select a subset of variables. It is a supervised machine learning method. Specifically, Lasso is a shrinkage and variable selection method for linear regression models. Lasso is actually an acronym for Least Absolute Selection and Shrinkage Operator. The lasso imposes a constraint on the sum of the absolute values of the model parameters, where this sum has a specified constant as an upper bound. This constraint causes regression coefficients for some variables to shrink towards zero. This is the shrinkage process. The shrinkage process allows for better interpretation of the model and identifies the variables most strongly associated with the target or response variable. That is the variable selection process. The goal is to obtain the subset of predictors that minimizes prediction error. So why use Lasso instead of just using regular ordinary least squares multiple regression? Well, first, it can provide greater prediction accuracy. If the true relationship between the response variable and the predictors is approximately linear, and you have a large number of observations, then OLS regression parameter estimates will have low bias and low variance. However, if you have a relatively small number of observations and a large number of predictors, then the variance of the OLS parameter estimates will be higher. In this case, Lasso regression is useful because shrinking the regression coefficients can reduce variance without a substantial increase in bias. Second, Lasso regression can increase model interpretability. Oftentimes, at least some of the explanatory variables in an OLS multiple regression analysis are not really associated with the response variable. As a result, we often end up with a model that's overfitted and more difficult to interpret. With Lasso regression, the regression coefficients for unimportant variables are reduced to zero, which effectively removes them from the model and produces a simpler model that selects only the most important predictors. In Lasso regression, a tuning parameter called lambda is applied to the regression model to control the strength of the penalty. As lambda increases, more coefficients are reduced to zero, that is, fewer predictors are selected, and there is more shrinkage of the non-zero coefficients. With Lasso regression, when lambda is equal to zero, then we have an OLS regression analysis. Bias increases and variance decreases as lambda increases. To demonstrate how Lasso regression works, let's use an example from the AdHealth dataset in which our goal is to identify a set of variables that best predicts the extent to which students feel connected to their school. We will use the same AdHealth dataset that we used for the decision tree and random forest machine learning applications. The response, or target variable, is a quantitative variable that measures school connectedness. The response values range from 6 to 38, where higher values indicate a greater connection with the school. There are a total of 23 categorical and quantitative predictor variables. This is a pretty large number of predictor variables, so using OLS multiple regression analysis would not be ideal, particularly if the goal is to identify a smaller subset of these predictors that most accurately predicts school connectedness. Categorical predictors include gender and race and ethnicity. Although Lasso regression models can handle categorical variables with more than 2 levels, in conducting my data management, I created a series of 5 binary categorical variables for race and ethnicity: Hispanic, white, Black, Native American, and Asian. I did this to improve interpretability of the selected model. Binary substance use variables were measured with individual questions about whether the adolescent had ever used alcohol, marijuana, cocaine, or inhalants. Additional categorical variables include the availability of cigarettes in the home, whether or not either parent was on public assistance, and any experience with being expelled from school. Finally, quantitative predictor variables include age, alcohol problems, and a measure of deviance that included such behaviors as vandalism, other property damage, lying, stealing, running away, driving without permission, selling drugs, and skipping school. Another scale for violence, one for depression, and others measuring self-esteem, parental presence, parental activities, family connectedness, and grade point average were also included. For more complete details on how these variables were constructed, see the Dicker et al. 2004 paper from Prevention Science and the SAS program called Decision Trees Data Management that have been made available as additional resources.